So today we are going to start with uh, two topics were left. One is clock and second is calendar. We're going to learn today clock and calendar both, right? So there are two topics. Will take some time and we'll try to complete. Okay, everyone. So now clock. You keep on answering this thing about the clock, right? Everybody. Means in a clock. Can you tell me how many divisions are there? We are talking about not digital but analog clock, right? So can anybody tell me that how many division you can have in a clock? Yeah, right. So there are 12 major. 12 major. If you start with here like 12, 3, 6, and 9. So there are 12 major division. How many minor divisions are there? How many minor divisions? Okay. That will be 60 minor divisions are there, right? Minor means like between to like 1, 2, right? 4, 5, 7, 8, and 11. So between these two, you know that there are 5 more divisions are there. So total divisions are 60. So when we talk about the clock, right, we know that in based of larger division there are 12 divisions, but smaller means 60. So this will relate with the minute, this will relate with the hour, right? Now my first question, just first question. What is the ratio of the speed of the minute hand and hour hand? What is the ratio of the speed of the minute hand and hour hand? Anyway, what is the ratio of the speed of the minute hand and hour hand? 5:1. How you got that? 5:1. Hour hand covers only hour hand covers only 5 parts. Think, not 12 parts. If you take a case that both are here, hour hand and minute hand. So after 1 hour, hour hand will be here. Right? So hour head must have covered 5 parts, while the minute hand must have covered 60 parts. So this is the ratio. So if I want to say the minute to hour, or you can say that hour to minute, this is 60:5, or you can say that 5:60. Sorry. And that makes 1:12. So this is very important ratio that you can use anywhere. This is the ratio between minute hand and hour hand, right? So this is the first thing that you should remember. The speed are in this ratio, 1:12. Clear this thing? Okay. Now next question goes in this way, right? Suppose I give you time, like 5:40. What is the angle between hour hand and minute hand? Anyway, at 5:40, what is the angle between the minute hand and hour hand? Anyone? Can you try this? At 5:40, what is the angle between minute hand and hour hand? Have you got that? 120. Yes. Okay. 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 And for 40 minutes? But oh, okay. My question is that is it something like this 540 times? Will the hour end exactly on the 5 or somewhere ahead than 5? You think and tell me. Because at 540, our end will be quite bit ahead than 5. If your 5 will be here, but our end will be somewhat more than half. Are you clear in this? So you are asked this angle. So now you try. Anybody, any idea? Look, I can go in this way. First of all, minute hand is on 8. I can say that every minute is equal to 5 degree because there are 60 division on 360-degree scale. So if I divide with this 60, I'll get the 360 and divide by 60, right? So that is called 6 degree. So every unit is taking 6 degree. So 8, 8 is 40 minutes. So 40 minutes means every minute equivalent to 6 degrees. So it is 240 degrees. Oh, so that is clear. So this is the degree covered with respect to 12 by minute hand. So this is 240 degrees. Now how much hour hand will move, right? So I can use this ratio. The ratio hour and minute hand is 1 is to 12, right? So if I want to find out how much hour hand must have moved, right? From 5 onwards, huh? Up to 5 to clear. Up to 5 is how much? So that is 5 hours into 30 degree. So that is the 150 degrees clear. But now I can go with that. At 5 o'clock, my minute hand was here. This was the 5 o'clock situation. Right? And then minute hand is covered 40 minutes. So by the time our hand has covered how much? So means I can go this way that this degree is how many degree? So 240 degree and then ratio I'll take 1 is to 12. Right? That means our hand has extra covered how much? So if ratio is 1 is to 12 is 40 divided by 12. This much extra 40 not sorry. 240 divided by 12. This much extra degree has been covered. And that is nothing but 20 more degree. Right? So total our hand has covered right 170 degree. And the answer is 240 minus 170. And that gives you 70 degree. Also understood. So if you do not want to get into this, I'll give you an equation. You call this h, you call this m, and the angle between is 11 by 2m minus 30 times h. You use this equation in absolute mode. 11 by 2m minus 30h, you'll get your answer. Let me see the. So theta is equal to 11 by 2, where it is 40 minutes and 30 times uh, hour, and hour means 5. So answer is this is 20. So 220 minus 150, and that is 70. So this equation, if you write down, this equation I just brought from this calculation, so, right? So this is better equation to remember. The theta in degree is equal to 11 by 2m minus 30h. This is your first question, right? So the first information write down, right? That h hour and m minute, the angle between hour and minute, this is your theory, 11 by 2m minus 30h. Then I'll give you some, you do it very fast using this. So no need to calculate much now, right? right? So I give you now means 710. Can you find out what is the angle at 710? Use this equation. At 7 and 10, what is the angle between minute and an hour end? Hope so understood. Everybody clear this? So when this will increase your speed, nothing else but you gain some speed using this equation. This equation is other way also known. So one more question. Try that. At 350, first question, second question, at 12, 12, 20, 12, 50, 12, 20 is good. At 12, 20. Find out these two questions. What is the angle between 3 and 15 and 12, 20? So anyone, any idea in this? First answer at 315. What is the angle between 10 and 11? The first answer is 11 by 2 into
433.5.
hmm. Just a minute, I'll calculate. So answer is 7.5 degree. You take absolute value only, right? The 7.5. Hope so understood. Now try with this next question at 12:20. Huh. How much it is? Okay. When you are given 12:20, you take 0:20. This is spatial thing. What will you take? Instead of 12, you take what? 0. Now you get your answer. So theta equal to how much? 11 by 2 into 20 minus 30 into 0. And that is equal to 110. Clear? This you take care of. When there is a 12, take 0. Right. So some spatial case I write down. If h equal to 12, right? Take h equal to 0. So this is spatial case, you write. If h is equal to 12, then take it what? 0. Right. So this is your theory number one. Right. So this is angle. So heading will be what? The angle between our hand and minute. Hmm. No, I hope so. They are not allowing. Some companies sometimes they allow it, but I feel so all these calculations won't take much time because what I've seen in the papers, you can do very fast. They are not giving such kind of calculation. If they give such calculations, which might be very much complicated, at that time they allow calculation. right? Otherwise, for simple, these are very simple calculations, so you can do it mentally also. Sure, should I go with next one? Right? Now, next is what? Suppose you given that between 5 and 6, at what time? What time? Angle between hands of clock will be 90. The question is that between 5 and 6 at what time, right? Angle between hands of a clock, right, will be 90 degree. So this time you have to find out time at what time this will happen. The angle will be what? 90 degree. So I'll tell how to solve this, right? I'll still use this equation. In this equation, I've given between 5 and 6. That means 5 is fixed, minute I don't know. And you are given theta, that is equal to what? 90. So I solve this sum using same equation where theta equal 90 equal to 11 by 2m minus 5 times 30 or 38. So 90 equal to 11 by 2m minus 150. Now when you remove absolute sign, you know that we have to keep plus or minus both. So 11m by 2 equal to 150 plus or minus 90. So 11m by 2 is equal to 150 plus 90. That means 240 or 11 by 2m is equal to 150 minus 90. So that is equal to 60. Right. So in this case, m equal to 240 double 480 divided by 11 or m equal to 120 by 11. So if 480 by 11 is 11 4s are 44, 3s are 33. This answer will be in fraction, right? This is 11 10s are 10 by 8. So that means there are two times. One is 5, 10, 10 by 11 minutes, and second time will be 5, 43, 7 by 11 minutes. These are the two times at which right the angle between the minute and hour hand will be 90 degrees. Hope so understood. Right? Should I
Can you
explain?
explain again, sir?
What you're telling?
Yes, sir.
Clear. So this is something that if you're given degree, how to tackle this, right? That you should take care. At what time between 11 and 12? The angle between, right, 22 degrees. So you try this. Once again, same type of question. What time between 11 and 12? Or between 11 and 12 at what time? Angle between hands of clock will be 22 degrees. Anyone? So once we use the same equation, like theta is equal to 11 by 2m minus 30h. We are given between 11 and 12 means 11 into means 11 hour and some m minute, and you are given theta equal to 22 degree. So I start with this 22 equal to 11 by 2m minus 30 into 11. So 22 is equal to or plus or minus 11 by 2m plus 330, right? So I'll go this way by 11 by 2m is equal to minus, sorry, this is minus 330 plus or minus 22. So 11 by, if I divide all with 2, so all with 11, I can say this is 30 plus or minus 2, right? So m equal to 60 plus or minus 4, right? So either m equal to 60 minus 4, that is equal to 56, or 60 plus 4. 60 plus 4 will not calculate because it is more than hour and that is not required. So answer is what? At 56. So here only one answer. 11, 56. The 11, 56, right? The angle will be 22. Also clear. Now, some direct question answer. Right? One question I'll ask you, but you remember as an information. That how many times? Like in this whole question in 12 hours. In 12 hours. How many times hands coincide? How many times hands coincide? First question. Second question. How many times hands are opposite? Hands are opposite. And third, how many times hands make 90 degree in 12 hours? So in a 12-hour duration, how many times hands coincide? How many times hands are opposite? And how many times hands make 90 degree? These three questions are very much reflected, and this is direct answer also. But anybody can try anyone. Like coincide means what? Then you can start with the 12. Both hands will coincide. Now after what time 1 second they will coincide? If you think in this way. So if you think that, so between 12 and 1 at 12 o'clock, right? Then 1 and 2, so roughly at 1, 1 roughly 5 point something, 1 hour 5 minutes. Between 2 and 3, so 2 or 10 minutes around. Exactly not, but something point will be there. Between 3 and 4, so it is 3:15 around or something more than that. 4 and 5, so 4:20 plus something, right? 5 and 6, so at 5:30 plus 6 and 7, so 6:35 plus meter. 7 and 8, so 7 and we can say that 7 between 7 and 8 ages. This will be 25 plus, sorry, 30 plus 35 plus 7. Then 8 and 9, so 8 and 40 plus made something. Then 9 and 10, so 9 plus something 45 minutes. Or 9, 45 plus something. 10 and 11, so that is 10, 50 plus. And 11 and 12, so it is at 1 second 12, right? So if you count, then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Because 12 once again came. That means they coincide 11 times. Coincides how many times? 11 times. The same way, how many times hands of the clocks are opposite? Same answer will be there 11 times. Right? And how many times it makes 90 degree? So you start this by yourself, it's 22 degree. Like we can say that every hour it makes 2 times 90 degree. Just we did one sum that in every hour it makes 2 times 90 degree. One time minute ahead, one time hour ahead. But between 3 to 4 and 4 to 5, between 3 to 4, right? It is at 3 o'clock and then 3 30 plus around. And between 2 to 3. So between 2 to 3, it will be like at 2 50 plus around and at 3 o'clock exactly. So this repeat 2 times here. That means in this 2 hour, instead of 4 times, it coincides 3 times. Between 2 to 3 and 3 to 4. Same happen between uh, 8 to 9 and 9 to 10. Here there should be 2 times, but at 9 o'clock it is common, right? So one time reduced from there, one time reduced from here. So total 22 times. So this three information, remember, nobody asked question then how you got the answer, but think that you remember, right? So how many times hence the opposite 11 times? Make sure that the format is of 12 hours. Sometimes they ask for 24 hours. And for 24 hours, you have to double this data. This is for 12 hours only. Right? For 24 hours, double this data, like 20 to 20 to 44. But also clear everybody. Right? So this is the type 2 questions, right? Let me go ahead. Next type of question is what? The clock is too slow or too fast, how to decide? Right? So after 12, suppose clock starts at 12, right? Once again, when the both hand will coincide with 1 o'clock. So we know that it will coincide once again somewhere after 1 o'clock. Somewhere after 1 o'clock, once again they will coincide. And when they coincide, angle between them is 0. So this is 1 hour and some minute is there. I say that as 1 hour, minute I don't know, but theta is 0 degree there. So I use that same equation by theta is equal to 11 by 2m minus 30h. This theta is 0, 11 by 2 m we don't know, and 30 into h is 1. So the answer is 30 equal to 11 by 2m. So m equal to 60 by 11, and m equal to that 4. So 5 by 11. That means this time is 1 hour, 5 by 11. That means how much time it must have spent. So suppose if I start from 12, then after 1 hour means 60 minutes and plus 5 by 11 more minutes, they will coincide. That means 60 plus 5 by 11. That means 65 5 by 11 minutes. Means both hand of the clock coincides at every 65 5 by 11. Why at every? Suppose I move this dial and I keep here 12 once again. Right? So this is my new condition. So 1 o'clock will be somewhere around here in that case. Right? And once again they coincide after 1 o'clock. Right? That means both hands always coincides at 65 5 by 11. Right? This number remember, very important number. Right? From this, we'll get some questions like this. So this is information. Hands of clock coincide at every 65 5 by 11. Okay. Now I'm asking one question. This is a true clock, but I'm having one faulty clock in my hand, and it coincides at every 65 minutes. Coincides at every 65 minutes. then my clock is too fast or too slow. My clock is too fast or too slow, right? So hands of faulty clock coincide at 65 minutes. Means less than this time, 65 minutes. This 65 minutes is not in my watch. Huh? True time is 65 minutes. But as soon as in other watch, which is not have any fault, in that clock, 65 minutes happen. In my clock, hands coincide. So my clock is running ahead than actual time or running back than actual time. Anyone? Means it is fast or slow.
Third slow.
It is slow.
Slow.
Anybody else? How you can got that answer faster? Yes, well, look, those who not understood understand that this is 65 minutes not in my watch. My watch hand coincides. As soon as hand coincides in my watch is showing this time. Because when hand coincides, this is actually shown by the my watch, which is what. But when I look at the real time in the other watch, it was 65 minutes, and my watch is showing 65 5 by 11. That means it is gaining 5 by 11 minute, right? At every 65 minutes, right? So now I'm giving you one theory, so not to get confused, right? Coincides at x minute, where x is less than 65 5 by 11. So first conclusion, clock is too fast, right? And second conclusion, clock gains 5 by 11, or clock gains 65 5 by 11 minus x. This one difference of time minute at every x minute. At every what minute? X minute. So this is the conclusion. Suppose it is 65, then clock gains 65 5 by 11 minus 65 means 5 by 11 minute at every 65 minute. So this is very, very important conclusion, right? So faulty clock sums are there. This is actual timing. If it is x minute where x is less than 65 5, right? Then it is too fast, first conclusion, and this theory is useful. Why this theory is useful? Suppose if I continue with the previous problem, that is coincides at instead of x, I'm taking x 65, 65. So what is the time shown by the clock? This faulty clock. When it's a miss, both miss, they will say that the faulty clock and the miss normal clock, right? Both are set at the same time, 12 o'clock in the morning. So, sorry, 12 o'clock in the night, right? So when the true clock is showing, right, morning 10 a.m., what is the time shown by this faulty clock? Right. So I think in this way, these relations are in minute. Both set at the same time at 12 night, right? So now 10 o'clock happened. So how many minutes actual minute has passed? Right. So actual minute has passed. So that means 10 hours into 60 minutes. That is 600 minutes. So I'll go in this way, right? That when the true time is 65 5 by 11, the clock is showing, right? Sorry, when true time is 65 minutes, clock is showing 65 5 by 11, or it is gaining 5 by 11, and in 600 minutes, how much does it gain? The answer was 600 into 5 by 11 into 65. So answer is 600 divided by 13. So something, if you divide it, rough calculation to get it like 4 are. So this is 8, 2. So 28. That means It is 428 by 143. So it must have gained this many minutes. Means it must be showing morning 10 o'clock and 428 by 143 minutes. This is the time shown by the faulty clock. So that's why this conclusion is very important, right? That what is the actual, right? How you can calculate that. So one relation we get that this relation. The clock in this many minute at every x minute. So in this many minute, how much does it gain? That's the question first, and you get your answer. The same way, another theory will be there, right? If you have written this, then will go with the next one. Write down this thing. So this conclusion is very important for the sum. Suppose the next case is given. Suppose this is written right. So next case is given that x is greater than 60. So in this case, the true time, suppose let me call it 66 minutes. So when in my watch, means real watch 66 minutes happen, my watch hence coincides. Means my watch is doing this much time. And real time is how much 66. So my clock is too slow. Right? So hence of the faulty clock coincides at x minute if x is greater than that. So the first thing is too slow. This clock is too slow. Right? And here same thing you have to do, but as x is greater than, other things remain same. So clock gains, not gain this time, lose. So clock loses x minus 65 5 value minute at every x minute. This time it loses. So write down this one, right? This is the type of the sum they're asking. Sure. So now, right, I start this thing. One question I'll give you that. Two clock set same time at morning 8 a.m. Right? The hands of the clock, right, is right coincides at every 66 minutes. At every 66 minutes. So if the true clock is showing 7 p.m., then what is the time in the faulty clock? What is the time in the this is true clock timing. This faulty clock also started at the same time, 8 a.m. But the true clock, when showing 7 p.m., what is the time in the faulty clock? Try this. What anyone answer? So if meeting at 66 minutes, where 66 is more than 65 by 11, so you take the difference. And this difference will be 6 by 11 at every 66 minutes. Now going this way. Total, how many minutes are there between 8 a.m. to 7 p.m.? So 8 a.m. to 7 p.m., that will be total 11 hours. 11 hours means total 660 minutes. Right? So going this way. In in 66 minutes, this clock loses 6 by 11. So in 660 minutes, how much does it lose? Translate 660 into 6 by 11 upon 66. Right? So answer is 10. So answer is 60 by 11. Right? So answer will be 5 by 11. So this clock will lose 5 by 11. And that's why the timing will be instead of 6 p.m. and from 600 we subtract 5. That means 54 minutes, 6 by 11 p.m. This is the time shown by, right, the 42. So it must have lost 5 by 11. Also understood everybody. Any doubt in this? So this is all about the clock, right? So clock will not show much more value. Miss, for your examination, this clock must have miss is having still some more, but your is not having much more than this. Right? Now we'll try with today. Next topic is calendar. This is interesting. Right? So what is this calendar actually? So calendar uh, is something that was developed over the period of years. But calendar is when initially calendar was developed, it was according to the previous ideas were there. Like still we are in Vikram somewhere and all that. But all these calendars are time-based calendars, and they are looking at the timings of the celestial bodies. Like some are sun calendars are there, some are moon calendars are there. So they are looking at the timings of the celestial bodies, right? Motion, and based on that, they identify the changes surrounding the atmosphere or might be in the local weather, and then, right, they divided some months or some number of days together. So calendar is all working on that. We are going to learn the right the calendar what we are using right now, right? So in that calendar, it is based on the motion of the Earth around the Sun. Based on this whole calendar has been developed. This calendar, when it was kept in the use, it was not started from the first date, like 1st January 0000. It was not like that, right? It was kept in between the thing which was going on. So this calendar never seen that date, 1st January 0000, right? But yes, you can always predict. They have considered, right? You do know or don't know, but they have considered 1st January 0000 was Monday, was considered Monday. So this calendar is a fixed date. 1st January was Monday, right? So this you keep in mind, right? So our calendar starts from this consideration that 1st January 000 is starting date. What was it? Was Monday. So this should be in your mind, right? Now, right? How this calendar works around the motion of the Earth around the Sun. So can you tell me how much time does Earth take to complete one revolution around the Sun? How much time does Earth take to complete one revolution around the Sun? Anyone?
365 days.
Hmm?
365 days.
365. Right. You can search it if you want to write now on Google. Exact time you give me, if you know. Anyone? It is roughly, if I'm not wrong, so it is 365 days, 5 hours, something around that. 45 or 51 minutes and some seconds. So this is actual time, right, that Earth is taking to move around the sun. 365 days, 5 years, and blah blah. Right? So that is called true year. That time is exactly called a year. Right? But it is not like that. Right? We are not taking this exact time. We are taking only 365 days for the first year. Means we are considering this much less. Second day, second year, 1 second, 365 days. Third year, 1 second, 365 days. But fourth year, to compensate this loss of 5 or some minutes, because all 3 years we not considered that. So we'll add 1 day and consider 366 days. So this sequence keep on going. Understand this one? So after 1 year, we are actually behind the time what Earth is taking around the sun. Second year also like that one. Third year also like that one. So in fourth year, what we are doing, we are compensating that one. But this compensation is not exact. It is actually more than what we should compensate. Actually, that problem happening. So every fourth year, we are going ahead of time. Is that much time not happen, right? But we are taking 366 days. So this keep on going up to like 97 year, 98 year, 99 and 100. This also we consider 365. This is 365. If you take 96 one, it was 366. But 100th year, we are keeping up 365 days, not 366 days. So every fourth year is 366. But your 100th year is 365. Why? So during this 100 years, we are going ahead of the time every fourth year, right? And to remove that, we remove 1 day on 100th year. This removal is actually more than what we should have done, right? So we can say that every 100 year, this first 100 years is 365 days, second 100 years 365 days, third 100 years 365 days, but 400th year, we are keeping off 366 days. Right. So this is something what they've designed based on that. But this addition is more than actual addition, right? Because we can add a certain terms of days. So then after this, scientists has taken decision because this is very much big period is there. So they decided that mankind in future will decide that in which year they will reduce 1 day to bring the whole time together, means motion of the earth around the sun exact time. So still at every 400 year, when we are taking one more day, we are ahead than time. So it is happening. Every fourth year we are ahead of the time. Every 100 year we are back of the time. Every 400 we are ahead of the time. Right? So this is happening. So now next removal is when that scientists will decide. Not yet happen, but they will decide that after 2400 years, they thought that we have to remove 1 day. But which day they have to be in agreement with everybody because of computer programming and all are working on the days. So from first they have to design. Hope so understood everybody. Right? So how we calculate calendar? How we are forming calendar? So let me understand this. Our whole calculation of the calendar is working on a number of weeks, right? Means we consider number of weeks as a major source. This is group of 7 days. Week means group of 7 days. When it over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Suppose this is Monday, then Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. Once again, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Once again, Monday, Tuesday, right? So this is a group of 7 days, right? Now here we derive a concept of odd day. What is odd day? So odd day means the day more than 7 days, right? But the range of odd day between 0 to 7, odd day between 0 to 7. So the number of days, when if you're given a group of days, from that if you remove the complete weeks, then remaining days are known as odd days. Let me assert this one. Suppose 11th day. So in 11th day is from 1 to 11, there is 1 week and 1, 2, 3, 4, 4 odd day. We'll think like that. So in 11 days of group, there is 1 week completed, and this 11th is the fourth odd day. Is what? Fourth odd day. So how to find out this part? So we'll take the group of the day and divide with 7. 7 times the 7. And means your 11 number is your fourth odd day. Now fourth odd day means what? So zeroth odd day. Zeroth odd day is called Monday. First odd day. Sorry, zeroth odd day is called Sunday. Very sorry. First odd day is called Monday. Second odd day is called Tuesday. Third odd day is called Wednesday. Fourth odd day is called Friday. Fifth odd day is called Saturday. Uh, Thursday, sorry. Thursday. Fifth is called Friday. And sixth odd day will be Saturday. We'll do our seventh odd day because when divided any number is 7, multiple of 7, when comes here, remainder is 0, and that is called zeroth odd. So zeroth is Sunday. First is Monday. Zeroth means end of the week. First means first day of the week. Second means second day of the week. Third means third day. So first day of the week, according to calendar, is Monday. Second day will consider Tuesday. Third day will consider Wednesday, Thursday, Friday, Saturday. Like this is you can consider any day because it's a circle only. But for calculation purpose, this will consider. So now to identify that any date or year or days, right? Their computer programming also you can work with it. Those who are working with the computer programming, you can go with this structure also. It works very nicely, right? So how they calculate normally, right? That which day will be there. So this is calculation. We calculate odd day. What will calculate odd day? Suppose when you start with the odd day in a normal year means it is 365 days are there. So in 365 days, how many odd days are there? So I divide with 7. 7 5s are 35 and 7 2s are 14. So 1 odd day. So the 31st December is the first odd day. 1 odd. I'm giving the odd day. So one normal year is 1 odd day. In a leap year, that fourth year, which is of 365 days, 366 days, sorry. So if we take here 6, this will be 6, and odd days are 2. So that 2 odd days. In a group of 1 to 4 years, 1 to 4 years is normal, and leap, or any one leap and 3 normal, any one leap and 3 normal. So every normal is in 1 odd day, and leap is in 2. So total 5 odd day. So in a group of 1 to 4 year, consecutive 4 year, 1 to 4 years, in which 3 normal and 1 leap year is having 5 odd days. Right? In a group of 100 year, right? So there are in 100 year, there are how many such 4 consecutive year pairs are there? So if I go with that 100 divided by 4, so it is called 25. That means that 25 pairs are there. But we know that 100th year is not a leap year. It is normal year. Right? And that's why I'll go in this way. Look, if I divide with 100, there is 25. This is a 25 group. And this group, one group of 4 is in 5 odd day. So all 25 group together makes 125 odd day. But I subtract 1 for the 100th year, there is 124 odd day. Once I divide with the 7, right? So 17 sevens are 119, right? So remaining left is 5. That means 1 to 100 is having 5 odd day. 1 to 200 years is having 10. 5, 5, 2 times 10 is 10 divided by if I do 7, so I'll get 3 odd day. 1 to 300 years. So 5 3s are 15. So 15 divided by 7. So 1 odd day. And 1 to 400 years. So that makes 5 4s are 20. But every 400th year is a leap year. And that's why I add 1 for it. So total 21 days, 1 odd days are there. And then 21 odd days, right? That is, right? 21 divided by 7. 7 3s are 21 is it is 0. Zero means it is ending. That means this is the last day of the year, like that one. Means from next day, Monday, Tuesday, Wednesday, Thursday will start. Clear? So this is all about the grouping of the odd days. So this one you write down first, right? Then we'll go with the sum. So how to calculate using this one, right? So we know that today's day and date. Today's day and date. Today is 26th March 2022. 26th March 2022. And we know that today is Saturday, right? So let me find out using this concept of calendar. We start from the beginning of the calendar, which was Monday. So first of all, with the year 2022 year. This is running of 22 years. So how many years are over? So 2021 year, right? In 22nd year, we are on the 26th date of March. This January completed, February completed, and March is going on. February is of 28 days, January 31st day, and March we are on the 26th date today. So these are the consideration, right? I mean, 2000 years, how many odd days are there? Now calculate odd days. So consider this one. Every 400 years, zero odd day. So how many 400 years are completed in 2000 years? So we can say that 5 times. And every times when you complete 400 years, zero odd day. Means 0 plus 0 plus 0 plus 0 plus 0. Means after every 400 year, you get addition of zero odd day. That means after 2000 years, there is no odd day. Right? Now 21 year. So this how to calculate. So we go in this way. This is 1 to 21 years. So 21, we divide with a group of 4 years. So 4 5s are 20. So I'm taking this concept because 1, 2, 3, 4, if you consider like that one, so it is normal, 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 and leap. So there are 5 such group of 4 years, 4 consecutive years, and one extra day. 5 4s are 20, and one of extra day. In this group of 5, right? Every group is having 5 odd days. It's a group of consecutive 4 years are in 5 odd days. So there are such 5 groups are there. So 25 odd day and one more. That is 21 year is a normal year. So one more means 26. So 5 5s are 25 plus 1 26 odd days are there. If I divide with 7, because our odd days should be between 0 to 6. 7 is a 21, that is what 5. This is 5 odd. January, right, is having 31 day. So in this 31 day, 28 means 4 weeks are over, remaining 3 odd. February means there is no odd day because 28 means 7 4s are 28. And March 26 means because 7 3s are 21 and 5 more odd day. Right? So if you now add all this odd day, 5 plus 3 plus 5, so total 13. First I divide 13 by 7. The 7 ones are 7 and 6. So today is 6th odd day. Today is 6th odd day. And our 6th odd day is Saturday. So today is Saturday. Today is what? Saturday. Today is Saturday. So this is the whole calculation how, right? This program you can write down for your computer also. Computer also, if you give the date, computer will give you date. Right? You can put this in program. And that's why every computer can have programs or general programs are running for these cases. Right? So this calendar is mathematics, whole mathematical thing there. Right? I give one. Can you find a day on this date? 15th August 1947. What was the date? Find out it. 15th August 1947. What was the day? So we consider up to 1900s. this many hundred years. 47 is when, so 46 years. In that August is January, February, March, April, May, June, July, and August, we are in 15 days. February 1947 is 28 days. January of 31 day, March 31, April 30, May 31, June 30, July 30. So now let me calculate. 1900 year, how many odd? So every 400 year there is no odd day. That means 400, I'll divide 1900 with 400. So 400, 4s are 1600. So 300 left. Means there are four group of 400 years which doesn't produce any odd day. So means all are 0, 0, 0, 0, 0. But there is 300 years left. It means 1600 onwards, 300 years left. And every 300 years, there is one odd day. And I've given the group 1 to 100 year 5, 1 to 200 year 3, 1 to 300 year. That is one odd. Now 46, how to calculate 46? This is 1 to 46 years. So divide 46 in a group of 4 because every 4 consecutive years produce 5 odd. So this is 4 tens are, or 4 11s are, sorry, 44, 2 left is. So this 11th group produce 5 odd day per group and plus 2 extra. So 55 plus 2, that is 57 odd day. And once again, I divide this odd day with 7. So 7s, 8s are 56. So 1 odd day will produce in 1 to 46 years. January produces 3 odd day, February 0, March 3, right? April 2, May 3, June 2, July 3, August. As is 15th August. So 15 divided by 7 if you do, then remainder is 1. Now I'll make once again group of possible then 7. So 2 plus 2, 4 plus 3, 7. Right? 3 plus 3, 6 plus 1, 7. So now I'm left with 1, 3 and 1. So total 5. That means there are the on this one it was fifth odd day. And fifth odd day was Friday. So it's a Friday. So 15th August 1947 was Friday. Clear, everybody? Hope so understood, everyone. You try one right now, everybody. You take your birth date and check with the day. I'll give you 5 minutes. And if you're not getting answer, you're in mobile phone, you can cross check, verify dates. So you check it out there. Right? You take one date, your birthday is better, and then you identify that are you getting day or not. If you're not getting, then let me know. I'll give you 5 minutes right. Everybody got?